All right, so here is the setup. I bought some spinach leaves, just took them out of the bag. They should be fairly fresh from the store. I put in 3 or 2.5 leaves into this flask. Notice I've got it surrounded by foil. And here's my light source that I'm going to be shining on it. What I want to do is add a carbon dioxide detector to this, shine the light, and then measure the CO2 produced or consumed by the processes going on the inside after I seal it and turn on, that is, the light. Important question. I seal it, I put the carbon dioxide detector, I turn the light on. What do you think's going to happen to carbon dioxide? Do you think it's going to go up? Do you think it's going to go down? Or do you think that it's not going to change much over the course of 8 minutes? Everybody make a prediction, but justify your prediction. If you think it's going up, state specifically why. If you think it's going to go down, state specifically why. So here is my carbon dioxide sensor. I'm going to Bluetooth the data over to the iPad here, and we'll graph the data. Take a look at the X and the Y axis. Notice the bottom is going to be time. The top is concentration. That's going to be amount per unit volume of carbon dioxide in ppms. ppms are parts per million. Okay, so if you have 500 ppms, that would be 500 molecules of CO2 per million molecules of air. Let's start collecting some data. We're not starting the experiment yet, but let's collect some data. All right, and there we are. We're measuring CO2. It's going up slightly. I am talking. Let's see if we can get it to spike a little bit. So I'm gently exhaling onto the probe itself. And then notice now that I'm not exhaling anymore, it's going to go back down. So it looks pretty good. Let's stop collecting data. So we'll turn that off. I'm going to get rid of that data because we're going to start the experiment now. Again, here's the setup. Light, foil. We've got a flask here, and we've got the spinach. So let's put the let's put the CO2 probe tightly into here. And I'm gonna get this set up and be right back. So here's the setup. Let's turn the light on. And let's get the data collection going. So we're down there low. Let's reconfigure the graph slightly. Let's take a look at what's going on here. Got the bright light. This is actually a grow light. So this has, this filters out some of the wavelengths that are not very good for photosynthesis, and it kicks up the ones that are. So we're in the blue-violet range along with red, and we've got fewer in the green and in the yellow. So it's filtering out the green and the yellow. Let's take a look at our data. Run 70 seconds. The time is in seconds. So we've gone over a minute. So this is nice and sealed. Boy, that's a good look at the data there. All right, 120 seconds. So we're at over 2 minutes, and we're still going down. Let's take a look at where we are. We're under 420 ppms, parts per million, and we're at time 140. Boy, that's still going down. I think we're gonna cut this short. We're gonna go maybe there. We're at 3 minutes right there. Maybe 1 more minute. It doesn't seem to be leveling off. Interesting. CO2's decreasing significantly. I wonder what's going on there. Here we are again. There's the setup. All right, so here's my data. And notice I've got time, and I've got carbon dioxide in parts per million. So it's a change in carbon dioxide per unit time. And what I did was I did a statistical slope analysis on the colored in area. That's a good representative sample of the slope of that data. And notice that's in the light, so I labeled that. And then here is my slope. And I want you to write that down. We have linear fit, so the equation for a straight line is y equals mx plus b, as you all know from Mrs. Smith, and who, by the way, is an excellent teacher. And notice we have a slope, and we have the y-intercept there, and the slope is negative 1.57. So there's our m value. Okay? And then again, notice there's our y-intercept, and we could go and see where that's going through. So there we go. All right. Now what we want to do is collect some more data, but this time we're going to prevent as much light as I can from getting in and see how the carbon dioxide values change then. So I'm going to set that up, and I want you to make a prediction. I'm going to try to get this to not let any light into the system here, and let's see what happens. And of course, we'll collect more data in the dark. All right, here is the container with the leaves. I wrapped it in foil, and then just to really kind of make sure that very little light gets in there, I wrapped it in this cloth. I also opened this, so I opened this to kind of start over now. So let air back into it, and let's take a look. Let's start collecting and make a prediction. Is the CO2 gonna go, we're talking about the change over time here. Is it gonna go up? Is it gonna go down? Is it gonna stay the same? Make a prediction, but justify your answer. Here's my run in the light. There's my slope over the course of, I don't know what that was, over the course of about 90 seconds. So let's start collecting. And there we are. So we're going to give it some time. There is my previous run. So notice we're going to go to right at 220. So we'll stop at 220. Again, that slope analysis, that's the rise over run, the change in y over the change in x. Notice the first run we had a negative slope. Analyzing rates of change are essential in science, chemistry, physics, biology. Rates of change. The change in the y over the change in x. Very, very, very little light is making its way in because it's double wrapped. So there's the Bluetooth sensor. Let's see what's going on here. Making our way towards 220 seconds. And, okay, looks good. We'll stop collecting data at that point. We've stopped collecting data. Let's concentrate on the dark. So I'm gonna get rid of the light run there just for a moment. And let's do an analysis here. I'm gonna do that real quick and get right back. All right, so here is my run in the dark. And I determined a slope of a representative sample of that line. Notice I labeled it as dark there. Let's take a look at the slope. So now we have a positive slope. We have 0.519 as our slope value. We have the y-intercept there, that b value. So let's compare the upward slope and the downward slope. So we'll throw in the other data. So now we're comparing the upward slope and the downward slope. What is going on? Why is the carbon dioxide going down with a fairly steep negative slope? Notice with the light on, whatever color that is, don't make fun of me for that negative slope. And then notice the positive slope for the dark. What is going on? Come up with an answer. Be ready to get called on. Okay, so I just kind of cleaned that up a little bit. And now we can see the dark run versus the light run. We can see the equation for the straight line over that representative sample of data. We could take a look at the individual. So notice I can just get rid of that run. And now there's my original light run that was going down. And get rid of that if I choose to. And then we could take a look, take a look and isolate at the data when we have the dark run. All right, we will be discussing what happened in class.